In this class, we will discuss we will discuss the design of same problem corresponding to stage 3, which is the ultimate condition. And you know very well that at the ultimate condition, the beam will finally fail by crushing of concrete in the compression zone. In other words, it means that the beam will be considered as failed when the strain in the extreme compression fiber reaches a value of 0.003. Do you remember this? इस साइड डेरिवेशन वगैरह हमने किए थे उस पर.
Yes, sir.
Okay, before discussing the design corresponding to stage 3, which is basically string design approach, we should discuss some basic assumptions involved in the mechanics of reinforced concrete beams. So the first one assumption, it is basically a plane section before bending remains plane after bending. This you are familiar with this assumption. When you were deriving the flexure formula in mechanics course, you have studied this assumption. And what does this mean? This assumption means that the section, if we take a section, for example, this is a beam, this is a simply supported beam, and if we take a section over here, so this section will remain plane even after bending. The beam will bend when a load is applied on this beam, but it will remain plane. For example, this is the section. So when the beam bends like this, so the section will, this is that section. There will be bending, but the section will remain plane. इसका मतलब क्या है? इसका मतलब ये कि, for example, this was the stress diagram, if you remember, at the ultimate condition. So you know that the compressive stresses will cause contraction of the member. Clear? So practically, the section will be compressed here, and it will be elongated in the lower fiber because there is compression in the top and tension in the bottom. But since this contraction and elongation within the section will be so small that it can be neglected for design purpose, so the plane section can be considered as plane for the mechanics of reinforced concrete beam. ये clear है?
सर वो दरमियान वाला पोर्शन थोड़ा ज्यादा नहीं हो जाता?
क्या मतलब?
ये जो बीम का सर, ये लोड अप्लाई होने के बाद, फेलियर होने के बाद जो दरमियान का पोर्शन होता है, तो नीचे टेंसाइल फोर्सेस की वजह से टेंशन ज्यादा हो जाता है, तो इसका वो वेट ज्यादा नहीं होता? तो
हाँ बिल्कुल ज्यादा हो जाती है. हाँ बिल्कुल, ये मैंने कहा कि practically there will be some undulation in the section, but we can ignore that for the design purpose. Clear? We will say that the section will remain plane even after the bending. Now is it clear to you?
Yes, sir.
But this assumption will not hold for deep beams. For deep beams, we cannot say that because for deep beams the undulation will be relatively more as compared to flexure beam. Clear? So for deep beams, this assumption will not hold. But since we are not discussing the deep beams in this lecture, so therefore the plane section will remain plane after bending. Assumption will hold for beams under the consideration. The second assumption is that stresses and strains are approximately proportional up to moderate concrete stresses up to 0.5 FC prime. ये already हम discuss कर चुके हैं. यानी अगर आप concrete की stress strain curve draw करें तो it will be like this. So up to 0.5 or 0.45 C prime, the stress and strains are proportional, which means that the Hooke's law is valid up to 0.5 FC prime. Which in other words mean that you can calculate the stresses directly from the strains by multiplying strain with the elastic modulus of concrete. Clear? However, when the load is increased, the variation in the concrete stresses is no longer linear. तो भी आप लोग पढ़ चुके हैं. At the ultimate condition, we have already studied that this will not be linear. It will like this. You can see this. The strain variation will be linear, that is, it will be proportional to the distance from the neutral axis. It will always be linear. Even at the ultimate condition, strain will increase as you move away from the neutral axis. However, the stresses will vary like this. Clear? Tensile strength, this is the third assumption. ये clear है? Second assumption.
Yes, sir.
Quickly
Clear.
respond. Tensile strength of concrete is neglected in the design of reinforced concrete beams. So this we have already discussed. I told you that after the crack, we assume that all the tensile stresses will be taken by the steel. So the tensile strength of concrete is completely ignored in the design. This is the basic assumption. Clear? You can see here all the tensile stresses are taken by the steel. There is no contribution of the tensile strength of concrete. Fourth assumption, and this is the main assumption, it is the bond between the steel and concrete is perfect and there will be no slip. That is, the bars will not slip under the given demand. अगर ये assumption valid ना हो तो फिर जो सारे calculations आप पढ़ते हैं those will not be valid अगर slip आ जाए इसमें, because all these calculations they are valid by assuming that the bond between steel and concrete remains perfect. And that is why we can calculate the strain at this location from the similarity of triangle. Okay. And if the bond between steel and concrete remains the perfect, then you can say that the beam will act as a composite section such that the tensile stress will be taken by the steel and compressive stresses will be taken by the concrete. Is this clear to you?
सर ये परफेक्ट किस केस में होता है, कैसे होता है और मतलब कैसे बनाया जाता है और ये स्लिप किस की वजह से होता है?
हाँ, परफेक्ट इस तरह होता है if the concrete can flow around the bars if the concrete flow around the bars and यहाँ पर आप देखें जरा, if this is a reinforced concrete section, if the concrete is poured and it flows around the bar, so what will happen? It will make a perfect bond with the steel, and at the given demand there will be no slip between the steel and the steel will not slip for the given demand. But if, for example, if we provide very high amount of reinforcement in a beam, so in that case what will happen? The concrete will not be able to flow around the bars, and there will be a weak bond between concrete and steel. So when we apply the loading on such beams, there will be slip between concrete and steel, and due to that slip there may be a premature failure of the beam. So in most of the cases, even if the reinforcement amount is small, the beam will not fail if there is perfect bond between steel and concrete. But even if we provide reinforcement more than that required by the analysis, but if there is no perfect bond between steel and concrete, so what will happen? Even the self weight of the beam will become a load on the steel. The section will not act in a composite way. Okay. In this case, the section will act as a composite section, such that the compressive stress will be taken by the concrete and the tensile stress will be taken by the steel. However, in this case, all the load will be taken by the steel alone, and it may cause a premature collapse of the beam. Clear? ये clear है कि नहीं?
Yes, sir. Yes, sir.
Fifth assumption is that strain in concrete and reinforcement shall be assumed proportional to the distance from neutral axis. ये already आप हम पढ़ चुके हैं. We can see that strain is proportional to the distance from neutral axis. What does it mean? That the strain value will increase as we move away from the neutral axis. Clear?
Yes, sir.
और ये assumption तो हम already पढ़ चुके हैं. The maximum usable concrete compressive strain at the extreme fiber is assumed to be 0.003. ये तो बार बार हम पढ़ते हैं. So the maximum concrete strain at which we can consider that the beam is failed is 0.003. This is basically the crushing strain of concrete. So this is clear to you now that the compressive strain value will be fixed. In case of strain design, the crushing strain will always be 0.003. So this value will always be fixed. Okay. But what about the strain in steel at the time of crushing? What about this value? Now this will depend on the amount of reinforcement. If the amount of reinforcement is relatively small, okay, so then the steel will yield well before the crushing of concrete, and in that case, at the time of crushing, the strain in the tensile steel will be greater than the yield strain. Okay. For example, for this case, the reinforcement amount is denoted by AS1. Acha, if you increase the amount of reinforcement in the beam relatively, so what will happen? The strain in steel will decrease or increase? G.
Decrease, sir.
Decrease, sir.
It will decrease. Definitely it will decrease because you are increasing the amount of reinforcement. So with increase the amount of reinforcement, the strain in the steel will decrease. Okay. So with relatively larger amount of reinforcement, there is a possibility that at 0.003 the strain in steel will be equal to yield strain. This is another possibility. Acha, this first condition is known as under reinforced condition. Clear? In which the steel has already yielded at the time of crushing. That is, at 0.003 strain, the tensile strain in steel will be greater than the yield strain. This condition is known as under reinforced condition, and this section is known as under reinforced section. ये clear है? अच्छा, ये भी हो सकता है that at 0.003 strain in concrete, the tensile strain will be equal to yield strain. So what does it mean? It means that crushing of concrete and yielding of steel will occur simultaneously. इसका ये मतलब है ना? ये clear है?
Yes, sir.
This condition is
Yes,
known
sir.
as balanced failure condition, and this section is known as balanced reinforced concrete section. If we further increase the amount of reinforcement, so then the strain in steel at the time of crushing will be even less than the yield strain, which means that the concrete will crush before yielding of steel. This condition is known as over-reinforced condition, and the section is known as over-reinforced concrete section. अब बात समझ में आ रही है? For example, the steel corresponding to balanced failure condition is denoted by AS2, and the steel corresponding to over-reinforced concrete section is denoted by AS3. So AS3 will be greater than AS2, and AS2 will be greater than AS1. इस तरह है ना?
Yes, sir. Yes, sir.
अच्छा, अब इसमें अगर आप देखें, these two conditions, that is balanced failure condition and over reinforced condition, these will lead to the brittle failure of reinforced concrete beam, because if you see first of all at the balanced failure condition, what will happen? The yielding of steel will occur simultaneously with the crushing of concrete. You will get no warning time, no enough time for escape. So this will be a brittle failure mode, because crushing of concrete is failure, and if the steel yields, just yields at the time of crushing, it will give you no warning signs before the failure. Similarly, the over reinforced condition is also a brittle failure. It will also lead to a brittle failure of the reinforced concrete beam, because even before steel yielding, the beam will crush, and you know that the crushing of concrete means failure, so the beam will fail even before the yielding of steel. However, in case of under reinforced condition, you can see that first of all the steel, the tensile steel will yield, and this yielding of steel will be followed by the widening of cracks and increased deflection in the beam, which you have seen in the beam test video, if you remember. And finally, there will be crushing of concrete after the steel yielding. So the steel would have yielded well before crushing, which will give you enough warning time. So this will lead to a ductile failure mode. This is a desirable failure mode. Clear? So we will always design a beam as under reinforced concrete section. Clear? For the under reinforced condition. Because we want our beam to fail in a ductile mode. So for the ductile failure mode, we need the under reinforced condition so that the steel will yield well before the crushing of concrete. जी क्वेश्चन पूछे
सर ये टेंसाइल स्ट्रेन और यील्डिंग स्ट्रेन पे थोड़ा समझाएं।
टेंसाइल स्ट्रेन तो एनी स्ट्रेन इन द स्टील, उसको हम टेंसाइल स्ट्रेन कहते हैं ना, और यील्डिंग स्ट्रेन तो एक फिक्स्ड वैल्यू होगी ना। यील्ड स्ट्रेन फॉर एग्जांपल फॉर गेट फुट इज 40 डिवाइड बाय 29000। क्लियर? तो 0.00138, दिस इज द यील्ड स्ट्रेन ऑफ ग्रेड 40 स्टील। तो कहने का मतलब ये कि फॉर अंडर रीइंफोर्स्ड कंडीशन द strain at the ultimate condition in the steel will be greater than this value. बात समझ में आ रही है? ये नहीं समझे?
यस सर समझ गया।
इसमें क्या कंफ्यूजन है?
क्लियर है सर।
This is another assumption, और ये already हम पढ़ चुके हैं in lecture 1, that the steel is assumed to be uniformly strained to the strain that exists at the level of the centroid of the steel. अच्छा ये तो हम ये भी मैं explain करूँगा। Also, if the strain in steel is less than the yield strain, the stress in the steel is equal to, you can calculate from the Hooke's law. This is the yield strain. This is basically the bilinear elastoplastic curve. You know that actually it will vary like this. This will be the actual stress strain curve. But we can assume the curve as elastoplastic curve, and if the strain in steel is less than the yield strain, you can calculate the stress directly from strain by multiplying this strain with elastic modulus. Clear? And when the strain in the steel is greater than the yield strain, so you can calculate the stress. So the stress in the steel will be directly, you can take it equal to Fy. बात समझ आ रही है? ये तो ऑलरेडी हम पढ़ चुके हैं ना।
Yes, sir.
अच्छा, अब यहां पर आप देखिए जरा, the steel is assumed to be uniformly strained to the strain that exists at the level of centroid. इसका क्या मतलब है? For example, this is a reinforced concrete beam. We have provided 3 bars in the first layer and 2 bars in the second layer. अच्छा, अगर इसकी अगर आप strain diagram बनाएं तो the strain diagram will be like this. G value तो आप लोगों को पता है, this is fixed, it will be 0.003. Okay. The stress in layer 2 will be E is 2, and the strain in layer 2 is E is 2, and the strain in layer 1 is denoted by E1. Clear? अब आप मुझे जरा बताएं which one will be greater, E1 or E2? Strain
ES2.
in layer 2 will be, यार आप लोग,
सर
this is
ES1
strain in layer 2
Sir,
and
ES1.
Sir,
this
ES1.
is,
Zero.
ये तो भी हमने पढ़ा, हाँ, the strain is proportional to the distance from neutral axis. So of course strain in layer 1 will be more as compared to the strain in layer 2. But for design purpose, if we calculate the centroid of this of these two layers, so we will assume that these strains and stresses will be resisted at the centroid of the reinforcing bars. Okay,
Excuse me,
so
sir.
we assume that since the stresses will be resisted at the centroid of the two layers, so that is why all these bars will be uniformly strained. And what will be the strain value? You can calculate the strain value corresponding to this centroid, and you can see this strain will be basically, you can calculate this strain corresponding to centroid of the reinforcement layer, and you can assume that all these bars are strained by this amount ES. बात समझ में आ रही है? एक्चुअली तो उस तरह नहीं होगा. Actually there will be strain in layer 1 will be more than the strain in layer 2. But for design purpose, we can assume that all these bars will be strained uniformly. And how to calculate that strain? You can calculate the strain by at the centroid of the reinforcing bars. जी क्या क्वेश्चन है? ये समझ गई बात कि नहीं?
Yes, sir. ये समझ गए सर. ये जो
This will
तीन
basically
बार
make
सामने
our
किए सर.
calculations very simple. जी जी
सर ये यहाँ पे सर हमने दो
दोबारा
लेयर में
पूछे.
सर बार्स दिए हैं सर. सर जो बटन वाले है उसमें 3 दिए और ऊपर वाले
हाँ
सर जो है वो 2 है, लेकिन जो स्ट्रेन है सर वो नीचे वाले का ज़्यादा है. तो हम ये कोशिश करेंगे कि सर स्ट्रेन को कम करेंगे. तो सर ये बीच वाला जो बार है सर इसका तो कोई फ़ायदा नहीं होगा फिर क्यों, क्योंकि ऊपर लेयर का स्ट्रेन ऑलरेडी कम है एज कम्पेयर टू द बॉटम.
बीच वाला कौन सा बार?
सर ये फर्स्ट लेयर में जो है.
नहीं, ये स्ट्रेन जो आप, अच्छा तो क्या वो तो अगर आप यहाँ पर 3 बार भी प्रोवाइड करेंगे, 4 बार भी प्रोवाइड करें तो स्ट्रेन विल बी लेस एज कंपेयर, बिकॉज द स्ट्रेन वी हैव डिस्कस्ड इन assumption 4 that the strain in the strain will be proportional to a distance from neutral axis. तो यहाँ पर अगर 2 बार भी हो, वहां पर 4 बार भी हो, तो तब भी स्ट्रेन इन लेयर 1 विल बी मोर एज कंपेयर टू द स्ट्रेन इन लेयर 2. मगर मैंने आपको कहा कि हम ये इस तरह नहीं करेंगे. For the design of beam, we will consider that all these bars, they are strained uniformly. What does it mean? It means that all these will have the same strain value, and we can calculate that strain by calculating the centroidal distance of these bars, and at that corresponding to that point we can calculate the value of strain. And this is this is known as the effective dip. ये जो हम effective dip calculate करते हैं तो हम किस तरह calculate करते हैं? Effective dip is basically the distance from the extreme compression fiber up to the centroid of the tensile steel. बात समझ में आ रही है कि नहीं?
Yes, sir.
So we assume that all these bars in layer 1 and layer 2, they will be strained uniformly. Clear? And they will resist the stresses at the centroid. अब आप देखिए इसको, the steel is assumed to be uniformly strained to the strain that exists at the level of the centroid. तो किस तरह आप कैलकुलेट करेंगे? वो ये वैल्यू है, आप देखिए जो रेड वन है। अभी आप लोगों को क्लियर है कि नहीं?
यस सर क्लियर है, लेकिन सर
Yes, sir, अभी clear है।
डिजाइन कैलकुलेशन तो बार वन के लिए, लेयर 1 के लिए होना चाहिए था, क्योंकि डिफॉर्मेशन तो नीचे से आएगी, लिहाजा फेल्यूर की चांसेस नीचे से होगी, लिहाजा कैलकुलेशन या डिजाइन तो फर्स्ट लेयर के लिए होना चाहिए था सर।
नहीं, फर्स्ट लेयर के लिए कैसे होना चाहिए था? फर्स्ट लेयर के लिए तो आप करेंगे, मगर दिस सेकंड लेयर विल आल्सो कंट्रीब्यूट इन दी कैपेसिटी, वो कंट्रीब्यूट नहीं करेगी। अगर आप इसकी वो बनाए स्ट्रेस डायग्राम, तो दी टेंसाइल फोर्स, this will be tensile force in the layer 1 and this will be tensile force in layer 2. हम इस तरह नहीं करेंगे, we will calculate only one component, that is T, and this T will be equal to this total reinforcement. This T will be resisted at the centroid of these two layers and it will be equal to the total steel area multiplied by the stress. अब बात समझ में आ रही है? But basically it will be composed of these two components.
Okay sir.
यहाँ तक clear है? So these are the basic assumptions. For the application of reinforced concrete mechanics. Clear?
जी सर।
अच्छा, ये बात तो अब आप लोगों को क्लियर है that at the ultimate condition the compression strain value will be always 0.003. ये तो अब क्लियर है ना?
Yes, sir.
And you can also qualitatively you can say that what will be the strain in the steel at the time of crushing. Tensile strain in steel, it will be greater than the yield strain or less than the yield strain.
Maybe equal to the yields.
Equal to the yield strain.
कैसे में भी equal to यार, मैंने तो आपको पहले ही बताया।
सर ज्यादा होगा क्योंकि
आप देखिए we will always design
under
we will
reinforced
always design or reinforce for the under reinforced condition.
yes सर ज्यादा होगा सर
It will be more than the yield strain. By how much ये हम आगे डिस्कस करेंगे, but this strain for a well designed beam, that the beam designed as per ACI code, the strain in the steel will always be greater than the yield strain, because this is the under reinforced condition and this is the design. This will basically, this section will lead to the ductile failure mode. Okay. अच्छा, ये कितना होना चाहिए? How much should be the strain in the steel at the time of crushing? So ACI provide a limit on this strain, and corresponding to that strain you can calculate the reinforcement, which will be basically the maximum amount of reinforcement to be provided in a beam. Clear? And you will always provide reinforcement less than the maximum reinforcement. So ACI code says that, for example, this is a beam. This is a reinforced concrete beams. This is the strain diagram. This value is fixed. This is 0.003. And what about this value? That is strain in the steel. We qualitatively know that this will be greater than EY or under reinforced condition. This is C. Now, since this strain depends on the amount of reinforcement, is that right? नहीं? So therefore ACI code puts a limit on the ACI calculate the maximum reinforcement by limiting the strain in the steel. And code says that this strain at the time of crushing, it shall be greater than or equal to the yield strain of steel plus 0.003. समझ में आ रही बात? इसका क्या मतलब है? इसका मतलब ये है that at the time of crushing the steel would have yielded and the strain in steel will be more than the yield strain. Clear? By 0.003 it will be greater than the yield strain by 0.003. बात समझ में आ रही है?
Yeah.
Yes, sir.
अच्छा, बेस्ड ऑन दिस अगर आप फॉर एग्जांपल इन इस वैल्यू की करस्पॉन्डिंग फॉर एग्जांपल आप एज्यूम करें दैट टेंसाइल स्ट्रेन इन द स्टील विल बी इक्वल टू EY प्लस 0.003, अगर इसके बेस पर आप रिइंफोर्समेंट कैलकुलेट करें so that reinforcement, that will be the maximum reinforcement to be provided in a beam. अच्छा, अब आप हमेशा जो reinforcement प्रोवाइड करेंगे that will be less than the maximum reinforcement, क्योंकि maximum reinforcement तो एक लिमिट है. So the strain in steel will always be greater than this value because you will always provide reinforcement less than the maximum reinforcement. तो reinforcement आप कम करेंगे तो strain की वैल्यू बढ़ेगी ना. ये पॉइंट समझ गए?
Yes, sir.
So corresponding to this
Excuse me, sir.
condition you can जी
सर आपने जो कहा कि सर ये जो हमारे साथ बैलेंस फेलियर रीइंफोर्समेंट है सर, ये हमारे साथ मैक्सिमम है, तो हम सर ये और रीइंफोर्समेंट कंडीशन क्यों डिफाइन करते हैं?
हाँ, ये जस्ट आपके अंडरस्टैंडिंग के लिए कि अगर आप reinforcement को ज़्यादा बढ़ाते हैं तो इस तरह के फेलियर भी आ सकते हैं, यानी बैलेंस फेलियर कंडीशन भी हो सकती है और reinforce कंडीशन भी हो सकती है अगर आप मज़ीद reinforcement को बढ़ाएं. तो इसीलिए तो यहाँ पर लिमिट है ना मैक्सिमम reinforcement की, that you should not provide reinforcement greater than the maximum reinforcement. आप reinforcement को बढ़ाएंगे एस मैक्स से तो मुझे ज़रा बताएं कि ET की वैल्यू कम होगी कि ज़्यादा?
सर कम होगी जब आप रीइंफोर्समेंट
कम होगी. तो it will approach to the EY, इस तरह है कि नहीं?
Yes, sir.
In a, it will approach to EY in a yield strain. So it will approach to brittle failure mode condition. बस समझ में आ रही है? जितना आप reinforcement बढ़ाते हैं, so उतना आपके पास the failure mode will be brittle. Clear?
Yes,
तो
sir.
इसी वजह से
Scaling
हम
mode.
बैलेंस फेलियर और वो ओवर रिइंफोर्स फेलियर उसको हम डिफाइन करते हैं। वो हम डिज़ाइन नहीं करेंगे उस पर, मगर आपको पता तो होना चाहिए कि अगर हम रिइंफोर्समेंट बढ़ाते हैं तो उसकी कंसिक्वेंसेस क्या होगी। क्लियर?
Yes, sir. Got it.
तो इसका मतलब ये कि आप रिइंफोर्समेंट बहुत ज़्यादा नहीं बढ़ा सकते, यानी आप रिइंफोर्समेंट बढ़ाएंगे तो आप कैपेसिटी तो ठीक है इंक्रीज होगी, बट द फेलियर विल बी converted from ductile failure mode to the brittle failure mode. So you cannot increase always the capacity by increasing the reinforcement in the beam. अगर आपको ज़्यादा capacity चाहिए, for example, तो you can increase the capacity by increasing the depth of beam. Clear? जरूरी
Yes, sir.
नहीं कि आप reinforcement से ही capacity बढ़ाए, सही? अच्छा, corresponding to this strain, for example, अगर हम कैलकुलेट करना चाहें, reinforcement को, that is very simple. This is the, if we this is the stress diagram. This is the compressive force and tensile force. First of all, you will calculate the C value, the small c value, which is the depth of neutral axis. So you can calculate that very easily from similarity of triangle. It will be equal to 0.003 divided by C. And what about this distance? ये किसके बराबर होगा?
Effective depth minus C.
Effective depth minus C. So this will be equal to strain in steel, which is equal to EY plus 0.003 divided by D minus C. आप इसको क्रॉस मल्टीप्लाई करें, so from this you can get the value of C equal to 0.003 divided by 0.006 plus EY into D. ये आप खुद कर सकते हैं, सही?
ओके सर।
Okay. C will be equal to 0.003 divided by 0.006 plus EY into D. Okay, so depth of neutral axis for gate 40 and 60, for gate 60 will be different because EY, that is yield strength for gate 40 and gate 60 will be different. EY for gate 40 will be equal to 40 divided by 29,000. It is equal to 0.00138, and EY for gate 60 is equal to 60 divided by 29,000. So it will be equal to 0.0021. Clear? If you put the value, these values in this equation, so C corresponding to grade 40 will be equal to, ये जरा calculate करें शाबाश, I think it is equal to 0.41.
Yes, sir. 0.4. Point 0.41 and 0.37.
0.41D or get 60 kg.
0.37.
It is 0.37 into D. From this, you can also calculate the value of the depth of compression blocks. So you know that A will be equal to beta 1 C, and beta 1 for FC prime less than or equal to 4000 is 0.85. So depth of compression block corresponding to grade 40, it will be equal to 0.85 multiplied by 0.41 into D. It will be equal to how much?
.35.
It is 0.34
0.35.
into D. And for grade 60, if we calculate this, so it will be equal to 0.85 multiplied by 0.37 into D, which is equal to 0.31 into D. Clear? Acha. Now, if we apply the equilibrium, so from equilibrium, you know that C will be equal to T. C is equal to 0.85 if C prime BA, and T is equal to AS if Y. अच्छा, अगर हम इस A को पुट करें, A is equal to this A, 0.34D. So if A is equal to 0.34D, so then AS will be equal to AS maximum. 0.85 if C prime B into 0.34D, it will be equal to AS maximum into Fy. This is corresponding to grade 40. Clear? अच्छा, अब इसको जरा कैलकुलेट करें. AS max will be equal to, इन दोनों को आप मल्टीप्लाई करें और मुझे वैल्यू बताएं. 0.34 मल्टीप्लाई बाय 0.85,
0.29.
so almost equal to 0.3 into FC prime divided by Fy into BD. So this is the maximum amount of reinforcement which is allowed in a reinforced concrete beam for grade 40 steel. Clear? क्लियर? अच्छा, अगर हम यहाँ पर ग्रेड 60 की करस्पॉन्डिंग अगर हम कैलकुलेट करें, तो यहाँ पर फिर हम ये पुट करेंगे 0.31D. यहाँ पर हमने कैलकुलेट किया है, इट इज 0.31D. तो यहाँ पर हम 0.31D अगर हम पुट करें, तो AS max विल बी इक्वल टू, ये जरा मुझे बताएं, 0.31 मल्टीप्लाइड बाय 0.85,
0.26.
0.27 almost into FC prime divided by Fy into BD. This is the maximum reinforcement corresponding to grade 40, and this is maximum reinforcement for grade 60 steel. Clear? So for a given size of beam, you can see this is the size of beam, width and effective depth of a beam. And for specified material properties, you can readily calculate the maximum amount of reinforcement for any size. But similarly, and since this is maximum reinforcement limit, so what does it mean? You will always provide reinforcement less than this maximum reinforcement. Okay, so this will of course ensure the under reinforced condition, because even at this stage, this reinforcement is calculated based on the strain value of EY plus 0.003. This value is greater than the yield strain. And if we provide reinforcement less than this in a beam, so in that case, ET will always be greater than EY plus 0.003. बात समझ आ रही कि नहीं?
Yes, sir.
यस सर। सर मेरा एक सवाल है
जी जी, क्वेश्चन पूछें।
सर, ग्रेड की बढ़ाने और कम करने से सर किसी भी सेक्शन के लिए स्टील की क्वांटिटी में कमी बेशी आती है कि नहीं?
हाँ बिल्कुल, आप देख सकते हैं ना, गेट 60 के लिए आपके पास रिइंफोर्समेंट लिमिट कम है, यानी आप कम स्टील प्रोवाइड करेंगे। गेट 40 के लिए आप बढ़ा सकते हैं स्टील को। आप देख सकते हैं ना, अभी 0.3 है और यहाँ पर 0.27 है, बाकी फैक्टर तो सेम है।
एक्सक्यूज मी सर।
जी जी
सर ये तो मैक्सिमम लिमिट है ना, और मिनिमम लिमिट कितना होगा?
मिनिमम लिमिट की तरफ आते हैं ना, पहले ये तो समझ गए ना,
जी सर, दैट्स क्लियर।
जो हम कर रहे हैं उस पर ज्यादा फोकस करें ना, जो आगे हम करेंगे ना, व्हाट विल बी द मिनिमम रिइंफोर्समेंट। अगर ये समझ गए कि नहीं?
Yes, sir. It's
समझ गया।
clear.
So for specified material properties and for a given section of beam, you can calculate the mixing amount of reinforcement. अच्छा, इससे आप reinforcement ratio भी calculate कर सकते हैं, और वो किस तरह, यानी आप इस BD पर इसको डिवाइड करें। यहाँ पर जरा देखें, this is AS mix is equal to 0.27 FC prime divided by FY into BD. क्लियर? अच्छा, इसको अगर हम दोनों साइड्स को BD पर डिवाइड करें तो ये तो कैंसिल हो जाएगा। This is known as reinforcement ratio. This is basically the area of reinforcement, area of steel divided by effective area of concrete. This is denoted by rho. So area of steel divided by effective area of concrete, this is known by rho, denoted by rho. It is basically reinforcement ratio. And maximum reinforcement divided by BD, it will be denoted by rho mix, and it will be equal to 0.27 FC prime divided by Fy. So for different material properties, that is for different concrete strength, and for gate 40 and 60, you can calculate these ratios. And if you know these ratios, so then for any size of beam, multiply just this ratio with the BD to calculate the maximum reinforcement. बात समझ में आ रही है? तो सिंपल है ना। फॉर एग्जाम्पल गेट 60 के लिए अगर हम करते हैं, ये गेट 60 के लिए इक्वेशन है, और गेट 40 के लिए रो मिक्स will be equal to 0.3 into FC prime divided by Fy. क्लियर? तो आप एक टेबल बना सकते हैं। This is grade of steel on this side, and on this side you can so for these different values you can calculate the reinforcement ratio. For example, for 3000 psi and grade 40 steel, what will be the reinforcement ratio? Quickly, शाबाश, जल्दी बताएं। यहाँ पर पुट करें ना यार, 0.3 मल्टीप्लाइड बाई 3 डिवाइड बाई 40, क्या रेशो आ रही है?
Sir, for 30, 0.03.
0.03
03.
नहीं आएगी यार,
0.02
इसमें क्या है यार? 0.02, 0.0225 ले, टोटल वैल्यू बताया ना। अच्छा, similarly for 3000 psi and grade 60 steel, what will be the maximum reinforcement ratio?
0.004.
यार ये आप लोग कैसे कैलकुलेट करते हैं?
0.015, sir.
0.015
आप लोग ये कैसे कैलकुलेट करते हैं यार? ये तो बिल्कुल सिंपल मल्टीप्लिकेशन, आप ये भी नहीं कर सकते। 0.27 मल्टीप्लाइड बाई 3 डिवाइड बाई 60, तो ये क्या वैल्यू आएगी?
Sir, 0.005.
0.015. 0.015.
0.0135.
0.0135.
0.0135। सिंपल आप मल्टीप्लिकेशन और ये नहीं कर सकते यार, ये तो ख्याल खराब है। अच्छा, इसके लिए कैलकुलेट करें for grade 40 and if you are using 4000 psi, what will be the ratio?
0.03, sir.
0.027.
Adnana 0.03 there. For 60 की shape of share video है.
Yes sir, good enough 60 दफा रख लें।
انت لا دي كده اف سي برايم او اف واي سي ویلیو ده په دې فارموله کې چې موږ پټ کوو
FC prime से मुझे कम stress given ये और FY grade by depend की मतलब 60 के बारे 60 है और 40 के बारे 40
यार que vi que una vacina बोलती है सड़े जस्ट वो अप्रूव है वापस
इधर इक्वेशन given दे वैसे कि putting the FC prime पर से जो कम stress given है put का और FY पर से grade मतलब 60 के बारे 60 और 40 के बारे 40 كرامة سرطة قالوا كوتي رازا بيارنج لك شو
आप लोगों को आवाज आ रही है?
यस सर अभी आ रही है
ओके, तो आप इसी तरीके से एक टेबल बना सकते हैं और स्क्रीन नजर आ रही है कि नहीं?
नो सर।
नहीं सर, नहीं आ रही सर।
सर स्क्रीन नजर नहीं आ रहा है
ये सर अभी शो हो रहा है।
अब आ रही है सर।
अच्छा, मैं दोबारा शेयर कर देता हूँ।
नहीं सर विजिबल है सर, स्क्रीन नजर आ
अब मेरे ख्याल में अभी इसमें कोई मसला है।
सर 10 मिनट का ब्रेक लेते हैं।
बस ये कंक्लूड करते हैं, फिर ब्रेक करते हैं। सही। अच्छा, अभी स्लाइड आपको नजर आ रही है कि नहीं?
यस सर।
कैन यू सी द स्लाइड्स? अच्छा, इसी तरीके से आप गेट 40 स्टील और 4000 PSI करस्पॉन्डिंग भी आप रिइंफोर्समेंट रेशो कैलकुलेट कर सकते हैं। मुझे क्विकली जरा बताएं शाबाश। 0.3 मल्टीप्लाइड बाय 4 डिवाइड बाय 40,
0.03 सर
what will be the value?
0.03
0.03. And what about for get 60 and 4000 PSI?
0.018
0.018. तो इसका मतलब ये है at least you should remember these two values because frequently we will be using 3000 PSI and get 40 or 60 steel in the design of beams. So you should at least remember these values. This is basically 2.25% of the, अगर आप इससे मैक्सिमम reinforcement कैलकुलेट करना चाहते हैं तो you have to multiply this value with BD. इस तरह है ना, क्योंकि तो रेशो है ना।
यस सर
तो 2.25% of BD. So you cannot provide more than 2.25% of the effective area of concrete beam for get 40 steel. अगर इसको आप करें तो it is coming 1.35% of the effective area of concrete beam. Clear? So
Yes.
at least you should remember these values. For get 40 steel, 3000 PSI concrete, you cannot put reinforcement more than 2.25% of the effective area. And for get 60 steel, दिस लिमिट इज 1.35%। क्लियर? ये वैल्यूज आप याद रखें। अच्छा, अब आप फॉर डिफरेंट साइज ऑफ बीम्स आप ये वैल्यूज कैलकुलेट भी कर सकते हैं। अब जरा मुझे बताइए आप, फॉर 12 by 18 inch beam, for 15 by 24 inch beam, 15 by 30 inch beam, ग्रेड 40 के लिए भी मुझे मिक्सिंग रिइंफोर्समेंट की वैल्यू बताए, और 60 के लिए भी। यानी अगर हम ग्रेड 60 यूज करें तो कितना मिक्सिंग रिइंफोर्समेंट डाल सकते हैं इसमें, और अगर ग्रेड 40 यूज कर रहे हैं तो कितना हम इसमें मिक्सिंग रिइंफोर्समेंट।
सर बस इस एरिया को उस परसेंटेज के साथ मल्टीप्लाई कर लेंगे 2.2 पर अपना 1.35 सर आ जाएगी
नहीं, इस एरिया के साथ नहीं मल्टीप्लाई करेंगे ना यार,
डी के साथ
ये आप
इफेक्टिव एरिया।
इफेक्टिव डिप यूज करेंगे। हाँ, तो ये आपके पास फॉर ग्रेड 40 इट विल बी इक्वल टू 0.0225 मल्टीप्लाइड बाई 12 मल्टीप्लाइड बाई 18 माइनस 2.5, तो इट विल बी इक्वल टू 15.5। क्लियर? और इसी तरह ग्रेड 60 के लिए आप कैलकुलेट कर सकते हैं 0.0135 मल्टीप्लाइड बाई 12 मल्टीप्लाइड बाई 15.5। बात समझ आ रही है? तो इसी तरीके से आप यानी हर एक साइज, डिफरेंट साइज ऑफ बीम्स के लिए आप मिक्सिंग रिइंफोर्समेंट करस्पॉन्डिंग टू ग्रेड 40 एंड 60 कैलकुलेट कर सकते हैं। ये पॉइंट समझ गए कि नहीं?
यस सर।
तो ये जो मिक्सिंग रिइंफोर्समेंट हम जो लिमिट है बाय एसीआई कोड, तो ये बेसिकली किसके लिए? दिस इज डक्टिलिटी रिक्वायरमेंट। क्लियर? If you provide less than the maximum reinforcement, so it will ensure a ductile failure mode. It will ensure that the failure mode will be ductile. Clear?
यप सर।
क्या तक तो clear है ना? Because the steel would have yielded will before crushing when the reinforcement provided in the beam is less than the maximum reinforcement. Clear?
यस सर।
Acha. There is also another requirement of ACI code, another limit, which is minimum reinforcement limit. अच्छा, जितना भी हम reinforcement कम करते हैं, तो you know that the strain will become less than EY plus 0.003। जितना reinforcement कम प्रोवाइड करेंगे उतना ही फेलियर डक्टाइल होगा, क्योंकि स्ट्रेन की वैल्यू
ज्यादा नहीं होगी इससे।
टेंसाइल रिइंफोर्समेंट एट द टाइम ऑफ क्रशिंग। जी,
टी ग्रेटर नहीं होगी जितने हम कम करेंगे रेनफोर्समेंट।
हाँ बिल्कुल ग्रेटर होगी। तो जितना ही, तो इतना ज्यादा डक्टाइल होगा ना। इस तरह है ना?
यस सर।
So then why we put a minimum reinforcement limit?
ताकि वो टेंसाइल फोर्सेस को तो रेजिस्ट कर सके ना।
अगर आप देखें, this is a reinforced concrete beam, for example. If you remember, corresponding to stage 1, that is just before the failure, just before the start, the just before the cracking. This is the strain diagram. The tensile stresses are taken by the concrete before the cracking, and you can calculate this tensile force before the cracking. This tensile force you can calculate. It is very easy, because the tensile stress just before cracking will be equal to 7.5 under root FC prime. We have already discussed कर चुके हैं. So from this you can calculate, this will be equal to, okay, which will be equal to 7.5 under root FC prime plus 0 divided by 2. Average stresses, tensile stresses in the bottom fibers multiplied by the area on which the tensile stresses are acting.
BH by 2.
What will be the area?
BH by 2.
It will be equal to BH divided by 2. So tensile force will be equal to 7.5 under root FC prime into BH divided by 4. आवाज आ रही है?
Yes, sir.
Yes, sir.
विवेक जरा बताइए शाबाश. आवाज सही आ रही है?
यस सर सही आ रही
आवाज कट रही है आपकी.
सर कट रही है.
So 1.875 into
Sir, 1.875 FC prime BH.
सर आपकी आवाज नहीं आ रही है अभी.
इसके लिए सुनिए।
अच्छा, अब आवाज आ रही है?
यस सर।
यस
Yes, sir.
हेलो,
यस
यस
सर,
सर,
आपकी
अभी
आवाज
आवाज
आ
आ
रही
रही
है।
है।
अब आवाज आ रही है आप लोगों को?
यस सर, आपकी आवाज आ
Yes,
रही है।
sir.
अच्छा, तो ये हम ऑलरेडी we started that why we provide the minimum reinforcement in a beam. So this is the stress diagram just before the cracking of concrete. You know this value will be equal to 7.5 under root of C prime. Okay, so average stress multiplied by the area on which these stresses are acting, this will give you the tensile force resisted by the concrete. It will be equal to 7.5 under root of C prime into BH divided by 4. This clear? ये क्लियर है यहाँ तक?
यस सर।
अच्छा, नाउ आप लोगों ने assumption में भी पढ़ा that we assume that just after the cracking all the tensile stresses will be resisted by the steel. There will be no contribution of concrete in resisting the tensile stresses. In other words, we will ignore completely the tensile strength of concrete. Clear? Just after the cracking. यहाँ तक क्लियर है कि नहीं?
यस सर।
Sir.
अच्छा, तो ये यहाँ पर जो आपने रिइंफोर्समेंट प्रोवाइड किया है, इसकी अगर हम कैपेसिटी कैलकुलेट करें तो इट विल बी इक्वल टू एरिया ऑफ स्टील मल्टीप्लाइड बाय यील्ड स्ट्रेंथ ऑफ द स्टील. यहाँ तक क्लियर है ना?
Yes, sir.
Now you know that after the cracking this tensile force will be resisted by the steel. अब क्लियर है?
यस सर।
Yes, sir.
तो अगर हम इन दोनों को इक्वेट करें, so ASFY must be at least equal to 7.5 under root of C prime BH divided by 4. Okay. Now if this is equal to this one, so this will be basically your minimum reinforcement. The minimum reinforcement required to resist this force. And इतना reinforcement कम से कम होना चाहिए so that after the crack it can resist this much force which was there in the concrete before the cracking. ये clear है ना? रिस्पॉन्ड करें ना?
यस
Yes,
सर।
sir.
अच्छा, ये अब जरा कैलकुलेट करें, शाबाश. AS minimum will be equal to 7.5 under root of C prime BH divided by 4 into FY. 7.5 divided by 4, ये वैल्यू जरा मुझे बताएं.
1.875.
So AS minimum will be equal to 1.875 into under root of C prime divided by Fy into BH. If we replace this H with the effective depth D, because in reinforced concrete design we will always use the effective depth. Okay,
Yes, sir.
so H is always greater than the effective depth and you can take it equal to 1.25 D. So यहाँ पर ये जरा पुट करें. h की वैल्यू अगर हम 1.25d पुट करें तो 1.25 और 1.8 से इसको मल्टीप्लाई करें
2.34
2.34 fc prime into bd divided by fy. So this is the minimum reinforcement limit, but code says that you will take this value equal to 3, and ये तो बिल्कुल लीस्ट है ना, थोड़ा सा अगर आप इसको सेफ साइड पर रखेंगे तो it will be equal to 3 under root fc prime into bd divided by fy. This is how the minimum reinforcement is calculated, and this is also for basically this is also ductility requirement, because if you provide less reinforcement than this, then soon after the cracking there will be abrupt failure of the beam, because as I told you that this tensile force which was resisted by concrete, after the cracking there should be minimum reinforcement which will resist this much force. अगर इससे कम हो, so after the cracking the steel will not be able to resist this much force, and there will be abrupt failure of the beam. So this is also a ductility requirement, so that the beam will not fail abruptly after the cracking, just after the cracking. Clear?
Yes,
So
sir.
this is how minimum reinforcement is calculated. But code says that you have to basically as per code the minimum reinforcement will be 3 under root fc prime, which we have developed, divided by fy, and this must be greater than or equal to, there is another limit, 200 divided by fy into bd. क्लियर? इसका क्या मतलब है? इसका मतलब ये कि आप ये दोनों वैल्यूज कैलकुलेट करेंगे, whichever is greater that will be your minimum reinforcement. अब बात समझ में आ रही है?
Yes, sir.
तो मिनिमम reinforcement रेशियो भी इसी तरीके से आप कैलकुलेट कर सकते हैं. ये दोनों अगर आप बीडी पर डिवाइड करें दोनों साइड्स, so this will give you the minimum reinforcement ratio, and minimum reinforcement ratio will be equal to 3 under root fc prime divided by fy greater or equal to 200 divided by fy. For different concrete strength and grade of steel, you can calculate the minimum reinforcement ratios. Clear? For example, for 3000 psi and grade 40 steel, what will be the minimum reinforcement ratio? Quickly जरा बताएं, शाबाश. इन दोनों को आप कैलकुलेट करें जरा.
First one is 0.129.
कैसे आपने कैलकुलेट किया?
सर 0.023.
ये आप लोग तो मैथ्स में काफी कमजोर है यार. सिंपल कैलकुलेशंस आप नहीं कर सकते. मैं आप लोगों को बार बार बता रहा हूं कि व्हेनेवर एफसी प्राइम कम्स इन स्क्वायर रूट, तो फिर आपकी यूनिट्स क्या होगी?
PSI सर, हमने
PSI में. तो ये आप PSI में आप पुट करें ना यार. ये भी PSI में पुट करें, FY भी PSI में पुट करें. इसी तरीके से यहाँ पर भी आप ये PSI में पुट करें. सही? अब वैल्यू बताए शाबाश, क्विकली.
4.108.
इतने आसान कैलकुलेशंस आप नहीं कर सकते यार।
4.1 into e power minus 3 सर यही आ रहा है।
ये आप इस तरह बताए ना 4.1, तो आप पूरी वैल्यू बताए ना, ये 0.00 क्या आता है?
0.0041
ये corresponding to this equation
सर
0.0041, and what about this equation?
0.005
0.005. Okay,
so minimum will be 0.005
which one will be governing? 0.005.
0.005
तो इसका मतलब ये कि 3000 psi for fc prime is equal to 3 ksi and fy is equal to 40 ksi. The minimum reinforcement ratio will be basically 0.5% of the effective area. 0.5% means 0.005 into BD. इस तरह है ना?
Yes, sir.
इसी तरीके से आप 3000 psi और गेट 60 करस्पॉन्डिंग भी कैलकुलेट कर सकते हैं। ये जरा बताएं शाबाश। इसमें भी यही इक्वेशन गवर्न करेगा और ये मैंने आपको लास्ट क्लास में बताया था। Why this equation will govern? ये आप
सर फर्स्ट वन से 0.0027
और दूसरे से
0.0033
तो कौन सा गवर्न कर रहा है?
सर द सेकंड वन
सेकंड वन। तो ये ऑलमोस्ट 0.33% ऑफ BD। So you should at least remember these values. For 3 KSI and get 40 steel, the minimum reinforcement is 0.5% of BD, and the minimum reinforcement for get 60 is 0.33% of BD. Clear?
यस सर
और ये मैंने आप लोगों को ऑलरेडी बताया था कि up to 4500 psi always this second equation will govern. और ये किस तरह आप कैलकुलेट कर सकते हैं? आप ये दोनों आप इक्वेट करें 3 under root fc prime if it is equal to 200, इससे आप कैलकुलेट कर सकते हैं fc prime की वैल्यू आपके पास ऑलमोस्ट आएगी 4500 psi। क्लियर? इसका क्या मतलब है? इसका मतलब ये है कि if the concrete strength is less than 4500 psi, then this equation 2 will govern, 200 divided by fy. And if the concrete strength is greater than 4500 psi, then equation 1, that is 3 under root fc prime divided by fy, this will govern. But since we are always using concrete strength less than 4500 psi in beams, so always the second equation will govern. Academic purpose के लिए तो आप दोनों कैलकुलेट करेंगे और दोनों से आप मालूम करेंगे, यानी अगर आप एग्जाम में क्वेश्चन हल करते हैं, बट ये आपको मालूम होना चाहिए कि this second one will basically give you the this will give you the minimum reinforcement. Clear?
Sir means maximum of both equations.
जी पूछे दोबारा।
Sir means maximum of both equations.
हाँ बिल्कुल, maximum of these two will give you the minimum reinforcement. तो फाइनली आप लोगों को कम से कम ये वैल्यूज याद होने चाहिए। बाकी तो आपके पास इक्वेशंस हैं, मगर कम से कम ये वैल्यूज आपको याद होने चाहिए that for get 40 steel for concrete strength of 3000 psi, fc prime is equal to 3 ksi for grade 40, the minimum reinforcement will be 0.5% of BD and maximum reinforcement is 2.25% of BD. इसी तरीके से grade 60 के लिए minimum reinforcement will be 0.33% of BD and maximum reinforcement is, it was how much? Do you remember? आवाज आ रही है?
Sir, 1.35%.
1.35% of BD. तो बाकी इक्वेशंस तो आप लोगों को पता है, आप उससे कैलकुलेट कर सकते हैं, मगर ये आप लोगों को कम से कम याद होने चाहिए बिकॉज वी विल बी फ्रीक्वेंटली यूजिंग concrete strength of 3 KSI and grade 40 or 60 steel in the design of beams. Clear? चलो एक ब्रेक करते हैं, फिर उस पर after the break we will solve a design example on this. Clear?
Okay,
ओके
sir.
सर
15 मिनट्स का ब्रेक करते हैं, सही?
Okay, sir.
ओके सर
आदिल भाई ये ग्रेड 60 के लिए मैक्सिमम रेनफोर्समेंट कितने परसेंट है? 1.35%। यस
Can you see the slides?
Yes, sir.
Okay, I think we should start the lecture. So we will solve the same design example. Using the stream design approach. This is a reinforced concrete section. In the stream design approach, you know that the compressive strain in the extreme compression fiber will be 0.003. And strain in steel, it will be greater or equal to EY plus 0.003. It will depend on the demand. If we draw the stress diagram, it will be like this. Because we know that the steel would have already yielded at this stage, so we know the value of Fy. So at the ultimate stage, you know the strain in the compression fiber, which is 0.003, and the stress in the steel is also known to you, which is Fy. The compressive force you can calculate from the compression block depth. The stresses are uniform, 0.85 Fc prime, and depth of the compression block is denoted by A. So this we have already studied that from equilibrium C will be equal to T. T is equal to 0.85 Fc prime BA and T is equal to A is Fy. And from this we have developed a relation in terms of for the compression block depth, which was equal to A is Fy divided by 0.85 Fc prime into B. This is how you can calculate the depth of compression block for a given size of beam with given reinforcement. Okay. Then we also calculated the flexure capacity at this stage, which was equal to T multiplied by lever arm, which was equal to A is Fy, and lever arm is equal to D minus A by 2. Now in stream design approach, this MR, it is denoted by Mn, which is basically nominal capacity of a reinforced concrete beam, which is based on the specified material properties. Clear? So this nominal capacity is equal to A is Fy into D minus A by 2. But since you know that in case of stream design approach, we have studied in lecture 1 that the demand will be amplified, that is the load will be multiplied by with corresponding load factors, and the capacities will be reduced. So this nominal capacity will be reduced by strength reduction factor, that is phi Mn. And this phi Mn, this is basically the design flexure capacity. If we multiply this Mn with the strength reduction factor phi, so then it becomes the design flexure capacity. Okay. Now, to avoid failure, the capacity shall be greater than or equal to the demand, and the demand you can calculate from the analysis. Okay, for a given load, you can calculate very easily the demand moment from the moment diagram. But for calculation purpose, you can take this phi mn equal to mu. Why? Because there's already the factor of safety has already been incorporated in this equation. Even if we take this equal to mu, there will be factor of safety, because in the mu you have multiplied the load with corresponding load factors, and you have also reduced this mn with strain reduction factor 5, and you know the phi value for beam, it is equal to 0.9. So this is equal to phi mn is equal to phi as fy into d minus a by 2. So from this you can develop a relation for as. as is equal to mu divided by phi fy into d minus a by 2. This is equation 2. Now this is how you can design a reinforced concrete beam for a given demand from these two equations. Equation 1 and equation 2. Okay. If you see in equation 2, all the parameters are known to you except compression block depth for a given demand, given size of beam with fixed material properties. These parameters will be known to you, but the value of A will come from this equation. But in this equation you can see that AS value is unknown. So what you can do in this case, mathematically you can solve this problem by two ways. Either you put the value of A in this equation and solve the equation in terms of AS, or you can solve this problem by trial and error method. Okay, so how can you do that? First of all, you will assume the value of A. You will put the value of A in equation 2, calculate the value of A's, and based on this, that is, recalculate the value of A, the depth of compression block, and for the two consecutive trial, if you get the same value of A's, that will be your design reinforcement. ये already हम discuss कर चुके हैं, clear है ना?
Yes, sir.
अच्छा, अब हम डिजाइन एग्जांपल पर आते हैं. If you remember, this was a simply supported beam. The span length is 20 feet. FC prime is 3 KSI and Fy is 60 KSI. You can assume the beam size. If you remember our working stress approach, we assume that the size of beam is 12 inch by 18 inch. However, you can select the size of beam, especially the depth of beam, from SAE table. Okay, so you will assume the width of beam and the depth of beam you can calculate from a table given in the ACI code. This is the table you can see here. For simply supported beam, the minimum depth, these are the minimum values, okay? The minimum depth will be L by 16. So in our case, what was the value of L? 20 divided by 16 multiplied by 12. These are quickly calculate करें शाबाश.
15 sir.
कितनी आ रही है?
15.
15 inches. But since this is minimum value, so you can provide a depth greater than this, but you will never provide a beam depth less than this value. Clear? So that is why we selected the beam size equal to 12 by 18 inch. अब ये बात समझ में आ रही है?
Yes sir.
Okay. So from ACI table, you can calculate the depth, the minimum depth of beam for different supporting condition. So for simply supported beam, it is L by 16. For 1 in continuous beam, it is L by 18.5. For both in continuous condition, it is L by 21. And for cantilever beam, it is L by 8. Okay. And these values, they are quite logical, because if one end is continuous, उस केस में क्या होगा? In case of simply supported beam, the moment value will be WL square by 8. This is basically the maximum moment which is possible in a beam subjected to uniformly distributed loading. क्योंकि आप देखें इसमें कोई redundancy नहीं है, there is no negative moment. However, in case of 1 in continuous beam, some of the moment will be distributed. Some of the moment will go to the support as a negative moment. Clear? So this moment will be reduced. इस तरह है कि नहीं? ये बात कैसे नहीं? देखिए आपके पास एक सिंपली सपोर्टेड बीम है, ये बात आप याद रखें कि सिंपली सपोर्टेड बीम के लिए जो आप मोमेंट कैलकुलेट करते हैं, दिस इज बेसिकली द मैक्सिमम मोमेंट. It is WL square divided by 8. Maximum moment possible in a beam subjected to uniform distributed loading. अगर हम इसको फिक्स करते हैं, इस बीम को अगर हम फिक्स करते हैं, तो अब आप मुझे बता सकते हैं कि what will be negative moment at the end. ये आप लोग एनालिसिस में पढ़ा होगा ना? ये मोमेंट कितना होगा? नेगेटिव मोमेंट फॉर फिक्स सपोर्टेड बीम सब्जेक्टेड टू यूनिफॉर्मली डिस्ट्रीब्यूटेड लोडिंग.
Sir, WL square. Divided by 4.
WL square by 12. Okay.
Yes, sir. Yes, sir.
But this total moment will remain the same. It is just distributed between positive and negative moment. This total moment will remain the same. It will be WL square by 8. If you subtract WL square by 12 from WL square by 8, you will get the positive moment at the center of fixed supported beam. ये अगर आप कैलकुलेट करें, so it will be, I think, WL square by 24. अब बात समझ आ रही कि नहीं? तो total moment will remain same. It will be WL square by 8. It will be just distributed between negative and positive moments. तो यहाँ पर अगर आप देखें तो for simply supported beam, the maximum moment will W square by 8. For one end continuous, of course, negative moment will be produced at the support. So this will be divided between negative and positive moment. So this value will be reduced. तो आप देख सकते हैं, you can also reduce the dip correspondingly. यहाँ पर L by 16 है और यहाँ पर L by 18.5 है. ये पॉइंट अब समझ में आ रही है?
यस सर।
अगर आप देखें बोथ इन कंटिन्यूस के केस में, तो इसमें आप देख सकते हैं कि the moment will be distributed between positive and negative moment. मगर आप देखें ये it will further be reduced because some of the moment from positive moment will go toward this support and some of the moment will be shifted to the left support as a negative moment. तो ये मजीद कम हो जाएगी, इस तरह है कि नहीं? पॉजिटिव मोमेंट, बात समझ में आ रही है?
यस सर।
तो आप करस्पॉन्डिंगली आप फैक्टर को भी देख सकते हैं. यू कैन रिड्यूस द डेप्थ ऑफ बीम करस्पॉन्डिंगली because the moment will be reduced for both and continuous as compared to simply support beam. ये हम डिस्कस कर रहे हैं उस केस को when the beams are subjected to same loadings. बात समझ में आ रही है? इसी तरीके से अगर आप देखें कैंटिलीवर बीम को, तो in case of cantilever beam, you know that the maximum moment will be at the support and the value of the moment will be equal to WL square by 2. So you can see that this moment is greater than the moment of simply supported beam by 4 times. Okay, so you can see that the depth of cantilever is also greater than the simply supported beam by 2 times. आप देख सकते हैं क्योंकि मोमेंट इसमें ज्यादा है ना. ये बात समझ में आ रही है आप लोगों की नहीं?
यस सर, आ रही है.
तो
Yes, sir.
using the ACI table, you can calculate the minimum depth of beam. But remember, this table is applicable for normal weight concrete and grade 60 steel. This is developed basically for normal weight concrete and the grade of steel is 60. Clear? For any other grade of steel or for lightweight concrete, you will apply modification factor to these equations. Clear?
Yes, sir.
For example, for any other grade of steel, you will multiply these value with this factor 0.4 plus Fy divided by 100,000, where Fy will be in psi. For example, if you are using grade 40 steel, so what will be this factor? 0.4 plus 40,000 divided by 100,000. So it will be equal to 0.4 plus 0.4. So you have to multiply all these value with 0.8 for grade 40 steel. ये बात क्लियर है? So for
Sir?
any other grade of steel, you will basically modify these equation by this factor. Similarly, for lightweight concrete, you can modify this equation by multiplying this equation with a lightweight factor, which is basically 1.65 minus 0.005 into weight of concrete, or 1.09, whichever is greater. ये WC क्या है? This is basically unit weight of concrete. So normally the unit weight of concrete is 150. For plain concrete, it is 145. But for lightweight concrete, this will be less than 145. For example, WC is 100 pound per foot cube. तो उस केस में फिर आप यहाँ पर ये पुट करेंगे, तो इट विल बी इक्वल टू 1.65 माइनस 0.5 1.15. तो ये 1.5 आप इसके साथ मल्टीप्लाई करेंगे. बात समझ में आ रही है? एंड रिजल्ट इसका क्या होगा? दिस द डिप विल बी इंक्रीज्ड बेसिकली. अगर बहुत ज्यादा लाइट वेट कंक्रीट नहीं है, लाइक फॉर एग्जांपल इफ द यूनिट वेट ऑफ कंक्रीट इज मोर देन 115 पाउंड पर फुट क्यूब, फिर उसके लिए इस मॉडिफिकेशन फैक्टर की कोई जरूरत नहीं है, because it will give you a value closer to 1. So this table is basically developed for grade 60 steel, for normal weight concrete and grade 60 steel. For lightweight concrete or for any grade, other grade of steel, you will basically modify these equation with corresponding modification factors. Clear? Another important note is that this table is applicable for normal spans subjected to normal loading. For longer spans or for spans which is subjected to heavy loading, this table will not work. उसके लिए फिर आप एक्चुअल सर्विसिबिलिटी डिजाइन करेंगे, यानी आप बीम की डिफ्लेक्शन कैलकुलेट करेंगे, and if the deflection in the beam satisfy the ACI allowable deflection limits criteria, so then that depth will be selected. बात समझ आ रही है?
Yes, sir.
क्योंकि इसमें आप देखें ना, it only depends on the length. इसमें लोड्स का कोई जिक्र नहीं है इस टेबल में. आप देखें तो ये जो हमारे पास इक्वेशंस है, जो टेबल है, it will be applicable for normal spans subjected to normal loading. Okay? यहाँ तक कोई क्वेश्चन है? तो आप
सर,
देखो इस तरीके से. जी जी,
ये लेंथ फीट में दिया गया है जो आपने L 20 लिया और
हाँ
20 by 16.
फीट में, ये
जी
फीट
सर.
में.
फिर हमने जो इंच में कन्वर्ट की ना, जो 12 मल्टीप्लाई की 20 by 16 को.
हाँ तो
नो सर, वही 12 का मैं पूछ रहा था सर.
हाँ बिल्कुल, वही हमने इंचेस में कन्वर्ट किया ना.
ओके सर, ओके.
क्योंकि डिप्थ ऑफ बीम हम इंचेस में लेते हैं. सही?
ठीक है सर.
अच्छा, अब दोबारा यहाँ पर आते हैं. The minimum depth required from ACI table is 15 inches, so I can choose greater than that depth. So in my case, it is 12 by 18 inches. Clear? And if you remember, the dead load was equal to 1 kip, 1.5 kip per foot, and the live load, it is equal to 0.5 kip per foot. And we are assuming that this load also contains the self weight of the beam. अगर आपको given हो that the self weight is not included, तो फिर आपने इसके साथ ही self weight भी include करनी है, because self weight is also a dead load. तो किस तरह आप कैलकुलेट करेंगे? Very simple. Area of the cross section 12 by 18, और इसको कन्वर्ट करें फुट स्क्वायर में, तो डिवाइड बाई 144 एंड मल्टीप्लाई बाई यूनिट वेट विच इज 0.15. So from this you can calculate the self weight of the beam. You will basically add this with the dead load. Okay, यहाँ तक समझ में आ रही है? मगर इस इक्वेशन, इस प्रॉब्लम के लिए हम एज्यूम कर रहे हैं that this self weight is already included in this value. Clear? अच्छा, अब हम स्ट्रेन डिजाइन अप्रोच यूज करेंगे. तो फर्स्ट ऑफ ऑल you will calculate the ultimate load or factor load. It will be equal to 1.2 into dead load, 1.6 into live load. तो ये वैल्यू जरा क्विकली मुझे बताएं. 1.2
2.6 sir.
It is coming 2.6 kg per foot. Now maximum moment for simply supported beam is equal to WU square by 8. तो ये जरा कैलकुलेट करें शाबाश. 2.6 multiplied by 12 square, 20 square divided by 8. जल्दी करें शाबाश.
130.
130.
130 sir.
130 foot. And if you convert this into inch hip, so it will be equal to 1560 inch hip. इस तरह है.
Yes, sir.
Yes sir.
Now using these two equations is Fy divided by 0.85 Fc prime B, and As is equal to Mu divided by phi Fy into D minus A by 2. Okay. First of all, you will assume the value of A, which can be assumed as 0.2D. So 0.2 multiplied by D is 15.5. Is how much? 3.1.
3.1 sir.
So to get the value of A's, यहाँ पर पुट करें और मुझे A's की वैल्यू बताएं शाबाश क्विकली. Mu is 1560, phi is 0.9, Fy is 60, D is 15.5 और इसमें 3.1 पुट करें. What is the value? शाबाश यार.
2.1 sir.
2.07
So
2.1
2.07.
Yes, sir.
2.07.
2.07 यहाँ पर पुट करें and recalculate the value of A. So it will give you 4.06.
4.06.
Again, based on this, recalculate the value of A's.
$2.14. 2.14 sir.
2.14. Shabash. Recalculate the value of A.
$4.196.
4.19. दोबारा ये कैलकुलेट करें.
2.15.
2.15. So these values are closer. So we will stop the trials. The design reinforcement finally for the given demand, it is 2.15 inch square. Okay. So the design reinforcement for the given demand, it is equal to 2.15 inch square. Now calculate the maximum reinforcement. What will be the maximum reinforcement? Shabash, quickly. जल्दी बताएं. 0.27 into FC prime divided by FY into BD. या इसके लिए आप डायरेक्ट भी कर सकते हैं. If you remember 1.35% of BD मैंने आप लोगों को बताया था. ठीक? What will the value?
2.51, sir.
2.51.
51, sir.
517. ओके. तो ये बस आप राउंड कर सकते हैं 2.52 इंच स्क्वायर. एंड व्हाट वुड बी द मिनिमम reinforcement? For get 60 and 3000 psi, if you remember, it was equal to 0.33% of BD. या आप इससे कैलकुलेट कर सकते हैं 3 under root FC prime divided by FY.
Zero point 0.61.
0.61 inch square. So since your design reinforcement, which is 2.15 inch square, it is less than the maximum reinforcement and it is greater than the minimum reinforcement 0.61. So the design reinforcement is okay. What does it mean? It means that if you provide this much reinforcement in the beam will fail in a ductile mode. Clear? If it is greater than maximum reinforcement, तो आप क्या करेंगे?
एक ही वैल्यू चेंज करेंगे इसमें शायद.
Depth value आप चेंज करेंगे.
नहीं.
आप depth को बढ़ाएंगे. You will increase the depth of beam. And if the design reinforcement is coming less than the minimum reinforcement, तो फिर क्या करेंगे?
तो reinforcement increase करेंगे.
नहीं, आप बस minimum reinforcement हाँ increase करेंगे या आप बस minimum reinforcement लेंगे डायरेक्ट. Clear? Now from this you can calculate the number of bars. So for example, we are using number 6 bar. For number 6 bar, the number of bars will be equal to total area of steel divided by area of bar. 2.15 divided by 0.44. So how many number of bars will be required?
4.88, so almost 5.
So almost 5 bars will be provided in the beam. Now, if you remember, I told you that if we provide all these 5 bars in the same layer, so then you have to calculate the clear spacing between these bars, because there is a limit on the clear spacing between the bars. अगर मैं इसको इसकी close-up view ले लूं, this is one bar, this is another bar, so this is the clear spacing between 2 bars. और इसकी requirement क्या है as per code? It should be
2.15.
It should be at least greater of 1 inches or dia of bar or 4/3 into maximum size of aggregate. Okay? Maximum of these 3 equations will give you the minimum clear spacing between these two bars. Clear? तो डाया बार तो हमारे पास 0.75 है. Usually we provide the 3x4 inch down concrete aggregate in the concrete. So this will be 3x4. So 4/3 multiplied by 3/4 will be equal to 1 inch. So minimum spacing between two bars, minimum clear spacing, it should be equal to 1 inch. But practically we recommend that this clear spacing, this is the code requirement. Clear? But we recommend that this minimum spacing, it shall be at least equal to 1.5 inch. Why? Because as I told you that the concrete must flow around the bars to form a perfect bond between steel and concrete. Clear?
Yes, sir. Clear.
तो आपको कम से कम यानी आप याद रखें कि ये क्लियर स्पेसिंग आपको कम से कम 1.5 इंच मेंटेन करनी है. कोड तो अलाउ करता है, यानी इसमें 1 इंच स्पेसिंग भी अगर आप प्रोवाइड करें तो कोड अलाउज यू, बट फॉर प्रैक्टिकल पॉइंट ऑफ व्यू we will maintain a clear spacing of 1.5 inch between these bars. Clear? अच्छा, आप इसकी ये जो स्पेसिंग है आप कैलकुलेट कर सकते हैं. स्पेसिंग बिटवीन दीज बार्स वो बिल्कुल सिंपल है. द टोटल विड्थ ऑफ बीम इट इज 12 inches. The occupied space is equal to 12 inches. जो भी आप इसको डिनोट करते हैं, फॉर एग्जांपल ओ से हम डिनोट करते हैं टोटल ऑक्युपाइड स्पेस
1.65.
सॉरी काल है.
So 1.3125.
अच्छा, कैसे ही कैलकुलेट करेंगे? शाबाश, आवाज आ रही है?
यस सर।
यस सर।
देखिए, अगर आप देखिए यहाँ से एक तो हमारे पास है ये क्लियर कवर
कंक्रीट कवर माइनस कर
टू
दो सर।
रिइंफोर्स। क्लियर कवर अगर आप देखें तो 1.5 इंच on one side and 1.5 inch on the other side, so it will be equal to this. फिर अगर आप देखें स्टिरप्स, स्टिरप की डाया यूजुअली हम यूज करते हैं 3/8 इंच, तो 3/8 इंच डाया on one side and 3/8 inch dia of strip on the other side, plus then the space is occupied by these bars, pipe number 6 bar.